Thanks you all for joining. My name is Nikhil Chandrappa. I'm a software engineer at YugabyteDB. I work in the drivers and ecosystem team of Yugabyte, where we work with integrating with popular developer tools like GraphQL, Spring Framework, Liquid-based, and host of other ecosystem projects. In today's session, I want to talk about how we can build scalable and resilient GraphQL applications. In the process, how we were able to scale the GraphQL subscriptions linearly to 1 million subscribers using distributed SQL databases. I believe many of the participants for this workshop have exposed to GraphQL in some form or fashion, right? It's super easy to get started. There are a few popular GraphQL server implementations out there. You take a GraphQL server, connect it to a database, and then you're ready to design your GraphQL queries using GraphQL console, right? However, when you have to move these applications to production, you have to consider a few day-to operations like the scalability of your stack itself. Like whether your entire stack, say you developed an application using GraphQL, right? And your app went viral. All of a sudden, you're having like 10x traffic, right? How do you scale your clients, the server, as well as the database? So currently, what we are seeing is sometimes the bottleneck can be like the single node traditional databases you use. And we're going to see how we can address that using distributed SQL in today's talk. And the secondly, you have to have a resilient application, right, for infrastructure failures. Many of us deploy our GraphQL applications in the cloud, and as we all know, cloud zones or regions can go out, right? There will be outages of some fashion, right? For that, the same reasons, you need to have your architecture so that they are highly available against infrastructure failures. The GraphQL server itself sometimes is like stateless, and the database, which is a stateful application, also need to be HA. So that's where we feel distributed SQL can help us, like YugabyteDB, right? Distributed SQL are the ones where you can scale out your relational workloads just by adding new node to the cluster. And also inherently, they provide high availability using and the native capabilities of sharding the data. And if even the part of the database actually goes down, your entire cluster doesn't go down, or your app will not be affected. And like if you want to scale out your database, and if you want to scale out your GraphQL layer, everything will happen seamlessly without any downtime. So for today's session, we'll be mostly talking about Hasura GraphQL Server and how Hasura GraphQL Server and YugabyteDB works together to build a scalable and resilient architecture. In order to just showcase these capabilities, right, we wanted to do a real world exercise. For that, we went ahead and we tried to linearly scale GraphQL subscriptions using Yugabyte and Hasura. So we all know GraphQL subscriptions have many use cases, right? Like it can be used for event-driven microservices. It can be used for creating dashboard purposes, notification. There's like a lot of use cases we are seeing currently where GraphQL subscription being used. And this was a really good feature for us to do some of these perf as well as the HA testing. For us, we wanted to simulate a real world use case. For that same reason, we took the e-commerce application where we'll have a bunch of users, and each users can have multiple user orders they can submit. So we simulated this, and we simulated a perf tool where we can have a number of user accounts, and each of them can get variable number of user orders. So depending upon like if you want to simulate a Black Friday scenario, you can specify the load for that kind of a scenario. That's what we'll be talking about, how we were able to scale today. So in our GraphQL set, before I actually go to the results itself, I just want to talk about the setup that we have for our benchmark exercise. From the GraphQL load generators, the GraphQL subscription simulators we have created, as well as the GraphQL engine, as well database, everything is running on Kubernetes on a cloud native environment, which kind of simplifies how for us to scale out the entire stack. Like the clients, the server, as well as the database can scale linearly. That's what we wanted to showcase as part of this demo. Let me go ahead and showcase my demo itself. I'll be scrolling between few screens here. I'll be scrolling between a few screens. I will be using my presentation as well as I have my console, the terminal where we'll be walking through a few commands. Let me go ahead and walk you through my setup itself, right? If you see here, this is my YugabyteDB cluster. This YugabyteDB cluster is also running on Kubernetes. It's a live YugabyteDB cluster. We are actively running workloads on it, the simulation we are talking about. And this is the one we are going to see how we can live scale this, as well as we are going to see how we can live scale the Hasura GraphQL engine, which is connecting to YugabyteDB. So as you can see in the metrics, we have GraphQL subscribers. We already have around 25,000 subscribers, which is connected to the database. That's why you see some load on the database itself. And also we have a GraphQL engine, which is our Hasura GraphQL engine. And if you could see, there's like few tables we have already already registered with Hasura. And if you see my subscription query itself, it's pretty straightforward. Or what I'm saying is, I want to subscribe for a user account, and whenever the new orders is coming, right? So that's what I'm doing here. And let me go back. This is our setup on the database and the Hasura. If you see, there's like two tables that we are subscribed to: user account and user orders. This is the one where we are going to be doing perf testing. And if you see, like I have a subscription where we have around 25,000 subscribers actually running. Let me go ahead and start a workload, right? I'll start my workload. This is like new orders. New orders are being written to the written into the system. I'm starting my workload, and if I go back to my database, I should now see new workload being written. If you see here, there's like new workload is coming to my system, and I can actively go ahead and scale out my database even with the live traffic. And even in such situations, my GraphQL subscriptions will be working fine. Let me go ahead and try scaling out my database here. I'll go, and it's as simple as just changing one parameter. I'll just change my database from 3 nodes to 4 nodes. This should go ahead and start my, I'll save this, and this should start creating a new load. So, and if you see here, my workloads are still running. So there is at no point in time I'll have any outages in my database, as well as there won't be any outage for the GraphQL applications itself, because they will continue to run. So if you see here, I have new events coming to my subscriber, even when we are scaling out the database itself. So that's how simple and easy is it for us to create a cloud native GraphQL architecture where the entire stack is scalable. Let me go back to my slide deck to show how we scaled this linearly, right? So using this, we were able to scale this setup linearly, starting from 25,000 subscribers to 1 million subscribers, just by adding new nodes to the cluster and also increasing the number of Hasura instances. This entire exercise, whatever we have, whatever I showed now in this demo, is actually documented in a Git repository where we talked about how we scaled to 1 million subscribers, the entire setup, as well as we talked about the high availability, what happens when you lose a node. If you are interested in the detailed study, please go ahead and check out this Git repository. That's it, folks. That's all I had in part of this short demo to showcase how easy is it for you to get started with distributed SQL and build a resilient and scalable GraphQL application. And as part of this conference, we also have a booth. Please feel free to join our booth. And also we are hiring across the entire portfolio. We have the core database, the cloud, as well as the ecosystem. Check out our careers page. Thank you.